Hello, welcome to the class of Managerial Economics, and today we'll talk about elasticity. Elasticity, if we see, is a study on the relationship between two factors or two variables. We try to understand the responsiveness of a dependent factor against the change in the independent factor. So if there are two factors, for instance, demand and price, and we wish to see what would be the impact on the demand of a commodity with a change in price, then demand being a dependent factor and price being an independent factor, we would estimate the change in demand brought about by a change in the price. So any change in a variable or a dependent variable brought about by a change in an independent variable is a study of elasticity. It is more like a correlation and understanding the nature of relationship, the direction of relationship, and the magnitude of change with a change in one variable bringing about a change on the other. So if we talk about law of demand or law of supply, the law of demand talked about inverse relationship between demand and price. That any change in price brought about an opposite change in the quantity demanded. The concept of elasticity is an extension to the law of demand or law of supply. So it would study that not only what would be the change in the demand brought about by a change in price, but what would be the level of that change or the magnitude of change. So we'll here be talking about two aspects related to elasticity. One is the direction, that is whether it is positive or negative. And the second part being the magnitude, that means what is the coefficient of this correlation between the two variables. So if we talk about elasticity, let's begin with elasticity today. So elasticity, as I told, elasticity is a concept that talks about the stretchability, the flexibility, or the variability, or in other words, the responsiveness of a variable against another. So if we talk about a dependent variable and its relationship with an independent variable, elasticity is all about understanding the magnitude of change and the nature of change that will be brought about in the dependent variable by virtue of a change in the independent variable. So in this sense, it talks about the stretchability or the elasticity of the dependent variable. In other words, how much is the demand variable or flexible against a change in price, or how much is the supply variable or flexible against or responsive against the change in price. Or in other words, if you're talking about, for example, income elasticity of demand, we're talking about how much is the demand variable against a change in income. So all this is the concept of elasticity. So the first thing we would try to understand is that when we say that it is the ratio of change in the dependent variable to the independent variable, there's a common mistake that we end up committing. Any change in the dependent variable against a change in independent variable is mostly referred to as the slope of a curve. So slope refers to the change in the dependent variable or one variable against the other. So if we look at the concept of graphing, we have a graph on the x-axis and the y-axis. Let's say there are two variables. I would still call them x and y. So any change in x brought about by a change in y would refer to the slope of the curve. However, elasticity as a concept is different from slope, because what we see is the slope remains constant throughout the curve. That means the rate of change let's take this point, the rate of change in y against the change in x is going to be constant throughout the slope of the curve, right? But elasticity is a concept that does not compare the absolute change in the two variables, but it tries to understand the ratio of change as a percentage change between the two variables. Let me give you an example. If let's say we have two vehicles with different size of tires being run at the same speed, we may see a different level of displacement that may be happening because of the circumference of the wheel. If they were to compete together, probably if you had a bicycle with small tires and your friend has a bicycle with larger tires, you would have to paddle much faster than your friend in order to cover probably the same amount of distance. So what we see is that when the two tires were not comparable in size, or they were not the same in size, there was a problem. of relative calculations. Same happens in case of elasticity, that if x and y being two variables, they may not have the same units of consideration. It's very difficult to understand the relative change between the two. For example, price and demand. If we talk about price and demand, or the quantity demanded, now these are two variables which are not directly related to one another. Price is in the units of rupees, quantity demanded is in number of units, and any change in the units against a change in price may not be directly comparable, because the number of units for both the commodities may not fall from the same category. So in order to bring a more rational understanding of the relative change, we are actually trying to see how much has the dependent factor displaced from its original value, and how much has the independent variable changed from its original value. So it's a kind of a study of a ratio of relative change between the two variables. So for example, if I say how much has the quantity demanded changed, I would take the change in quantity demanded against the original quantity, and the change in price against its original price. So the concept here becomes, it is a ratio of percentage change in the dependent variable against the percentage change in the independent variable. So that's how elasticity differs from the concept of slope. So let me compare the two. If I were studying change in x upon change in y, this is a concept of slope. But if I'm saying percentage change in x against percentage change in y, this is the concept of elasticity. So if we actually break this idea of percentage change, we see what does it mean is, it's a percentage change means it's x1 minus x0 upon the original x0 into 100, and the whole being divided by y1 minus y0 upon y0 into 100. Now if we see on cancellation of these two values, what we see is that it is x1 minus x0, which is nothing but the change in x, upon x0 into y0 upon y1 minus y0. If I reschedule this or retranslate this equation, what I find here is that it is nothing but x1 minus x0 upon y1 minus y0 into y0 upon x0. In other words, it is nothing but change in x upon change in y into the original y upon original x. And now compare this with the formula for slope. It was change in x upon change in y. So this refers to the slope, while this refers to the elasticity. And if we actually see this formula, it very clearly tells us elasticity is what? It's not just the slope, just the change between x and y, or relative change between the two, but the change in x from its original value compared with the change in y from its original value. So it is, in other words, if I treat change in x as marginal change in x upon marginal change in y, which is the slope, elasticity is the study of marginal change in x from, if I take this value from original value, I may take it as an average. So I may say average change in x whole against marginal change in y against its original or average change in y. So we'll talk about this further in this session. So to understand elasticity, we are now trying to understand that what probably as an extension to the law of demand and supply, what would be the magnitude of change in a commodity brought about by a change in the price. So let's go back to the law of demand for a while and understand quickly. We said law of demand talked about that how does the demand or the quantity demanded react to a change in price for normal goods, and we saw that the price and the quantity demanded were inversely related to each other. Now this was a case for normal goods. For other commodities which are not so normal, there could be the necessities, there could be luxuries, there could be inferior goods, there could be superior goods, there could be goods of conspicuous consumption, as we call them Veblen goods, there could be extremely inferior goods called Giffen goods. Every product will vary depending on its nature in elasticity, in terms of its flexibility. Just to make it very simple, that necessities may not be elastic in their nature, because you would continue to buy them regardless of change in prices. But if we talk about normal goods, the demand would be varied according to the change in price in order to manage your budget. With luxuries, things may vary in a different manner. If I talk about income elasticity of demand, for normal goods, the demand for goods will increase with income. But for luxury goods, you may find that it may increase much higher with a rise in income. While for necessities, the change or the increase in the demand for these goods may not be, or rise in demand for these goods may not be as much with a change in income as it was for normal goods or for the luxuries. So that's how elasticity varies as a concept, but we'll keep it very short and simple for this session. So now when we're talking about this elasticity, we found that the price and quantity demanded were inversely relational, and that showed that the price and the quantity demanded and the demand curve dd dash showed a negative relation. That means if I take a demand function and I say, given the price of a commodity and the quantity demanded of X, let's say the original price of a commodity was rupees 10 and the demand of that commodity was 100. And we say that when the price reduced to 8, the demand went up to 150. So we are trying to see what is the impact on the demand of a commodity brought about by a change in the price. And if we plot these values, P of X and QD of Y, we would get a certain slope of the curve, and it may be a gradually sloping curve or a steep sloping curve or maybe a rectangular hyperbola. So what we see is if we try to plot these values from 5 to 10 for price, and let's say 50, 100 and 150, what you find is that initially the price was rupees 10, the demand was at 100. Let's say, so it was at 100. Let's take this as 100, let's take this as 200, let's take this as 300, and here it is 5 and 10. Now we see that with the fall in price to 8, so this is 5, let's say the price fell to rupees 8, which is here, and the demand went down to 150, but 150 is somewhere here, so we'll take it here. And if we take this curve, we see that it's a slightly gradually sloping or a flat curve. Now, so one thing is the nature of the curve. The curve that you receive, that you derive out of this can be a steep sloping curve, it can be a flat curve, it can be a rectangular hyperbola, or anything like that. So this slope being different, the nature of the curve would definitely show whether the demand was high on elasticity or low on elasticity. For example, if we see, we would realize that initially with the price, this was the quantity demanded, and when the price went down to 8, the demand shifted to 150. So the ratio of change, if we see, there was a lesser change in the price, but there was a higher change in the quantity demanded, which is visible in this curve. A slight change, let's see here, a slight change in price brings about a larger change in the quantity demanded, so you get a flat curve, which is visible like this. So there's a greater change in quantity demanded against a smaller change in the price, and that's why you get a flatter curve. This is something what elasticity talks about in terms of the magnitude. Now, how do we calculate this magnitude? The formula, as discussed earlier, is percentage change in quantity demanded against percentage change in price. So if we go by this formula, what we find is that the percentage change in quantity demanded is obviously 150 minus 100, right, divided by because we are taking a percentage change, and I give you an easier derivation of this formula because the percentage 100 gets cancelled, so it's change in quantity demanded upon change in price into P original upon Q original, if you remember. So going by the same formula, it's going to be, this is 50. How much is the change in price? It is 10 minus 8, which is equal to 2. So what we see is that it's a change in demand or quantity demanded from 50 to a change in price to 2. And the original value, if we see, and we treat these as original values, the original price was at rupees 10 and the original quantity demanded was at 100. So what we see is it's going to be 5 by 2, and which shows that the value is coming out to be 2.5. Now, how do we interpret this value? But before we interpret this value, if you remember, I talked about two aspects. One is the direction and the other is the magnitude. So if we talk about this formula, we would see that this change was actually negative. It was a change from 100 to 150, so it was a minus 50. So whenever we'll talk about two factors which are inversely related, you would find, for example, it is price versus quantity demanded. But if we talk about price versus supply, the answer would be positive because they are both moving in the same direction. Either it is a negative value by negative value, which makes it positive, or both are going to be positive. So elasticity, the rule is that we drop this negative sign. We drop this negative sign because the negative sign only talks about the direction or the direction of association. But the magnitude of elasticity, so direction means that if it is negative, if a variable x is going is increasing, variable y might be decreasing. But on the contrary, if it is if the magnitude is coming out to be positive, it means both the values are either going upwards or downwards. So we drop this sign because sign only talks about the direction, and we know whether it's a negative or a positive association, and we only take the value or the magnitude. So instead of a minus 2.5 in the previous case, we would take it as 2.5. Now how do we read the magnitude? So sign talks about direction. The sign positive or negative talks of the direction, and now we are going to talk about the magnitude. So generally there are 5 magnitudes of elasticity. We'll talk about 5 magnitudes. We'll first talk about demand, and because they are inversely related, and then we'll take an example of a positive correlation like the price and the supply, or income and demand for normal goods. So if we talk about elasticity, the magnitude of elasticity, and how do we show it? I gave you an example in the previous lesson that it is price elasticity of demand can be shown like this, where price is an independent factor, demand is a dependent factor, and E refers to elasticity, and this part shows elasticity of the variable that we are studying, taking into consideration. So the elasticity normally varies between 0 and infinity. And the other broad categories that we may have for magnitude are less than 1, and we may have equal to 1 and greater than 1. So there are 5 common magnitudes of elasticity that we normally study. And going by this logic, if we look at the diagram, we would understand that the elasticity would vary in terms of the slope of the curve here. So we saw that in case this is the price and this is the quantity demanded, for all the cases, we would find that if the change in price is the same as change in the quantity demanded. For example, let me draw something like this. The change in price is same as change in quantity demanded. You would get a rectangular hyperbola. So this shows the concept of unitary elasticity where E is equal to 1. Let's take an extreme case where elasticity is equal to 0. It means that the demand or the quantity demanded for that commodity does not change, or there's a hardly very insignificant change in the demand because of change in price, and that's what we call as inelastic. So inelastic or zero elasticity would be shown by the fact that if the price keeps changing, we virtually see no change in the quantity demanded of a commodity. So the curve you see is a vertically sloped curve, and it's a tangent to the x-axis, and this shows that elasticity here is 0. While on the contrary, if we talk about elasticity being close to infinity, these are extreme cases. They may or may not be visible in most cases, but then theoretically they are applicable. And here we see that without much change in the price or almost no change in the price, you find the demand for a commodity fluctuating very often. So if we see, I'm sorry for this, let me just correct this, yeah. So we see that in this case, the demand keeps fluctuating with a given standard price, and it can be initially here, then here, and here. So this gives a case of zero elasticity, where you get a horizontal curve, and which means that the elasticity is infinite. With any change, there could be any change in the quantity demanded against a certain price without an insignificant, even an insignificant change in the price, the demand might be variable and fluctuate very often. So these are the 3 curves that show the elasticity being 0, 1, and infinity. Now we obviously can make out that the 2 values of less than 1 and greater than 1 would be somewhere in between the 2. So from an absolutely vertical curve to a rectangular hyperbola, you would get a steep sloping curve for elasticity less than 1. That means the variability of demand against the change in price is lesser in ratio, and so this is a relatively inelastic or less elastic demand for a commodity. And on the other hand, if we talk about a higher elasticity which is greater than 1, that means the change in demand has been more in proportion to the change in the price, and you get a more steep sloping curve which would show that a slight change in demand or a lesser change in demand brings about a greater change, in price brings about a greater change in the demand. So that's what elasticity is all about. So now going by this method, what we saw in the previous calculation was that the elasticity coefficient came out to be 2.5. But there is something still very interesting in this concept to learn about. And for that, I would like to confuse you a bit, but that confusion will lead to a greater clarity about what elasticity is all about. So we'll take the same values that we took earlier, or we would, I think that'll be, I'll take a fresh case for you to make life easier. So let's say we again have the price and the quantity demanded given to you. And let's make it a little simple. When the price was 10, the quantity demanded, we said, was let's say 100, right? And when the price comes down to 5, the quantity demanded goes to 200. Now there are two things we would like to notice here. We see, or let's say, let me just make it a little simpler, 150, it goes up to 150. Now what you say is a relative change of 5 here and a relative change of 50 here. So when we studied slope, we realized what was the mistake with that formula, that if we just take change in demand against change in price, we would find that the demand is substantially high compared to the price if I compare the absolute values 50, which is much, much, much greater than 5. But if we look at 5 as a percentage change in the original value, the change in price was 50%, and the change in demand, if I say 50 as a proportion of 100, again, it increased by 50%. So when the demand fell by 50%, the price fell by 50%, the demand, expanded by 50%. The quantity demanded, expanded by 50%. That means percentage gives us a much clearer picture than just the absolute change between the two values. And that's the reason we had come to this formula of percentage change in the dependent variable against the percentage change in independent variable. Right. Now we'll move ahead. There are certain shortcomings of this formula as well, and that is what we'll explore in this case. So let's say again the price and the quantity demanded are given to you, and the price is 10, demand is 100. The price goes up to 20 and the demand comes down to 50. Now what is the relative change here? It is 10, right? And in this case it is 50. And even if I would have gone by the previous values, if you remember, we said it was demand was 100 at 10 rupees, and when it came down to 5, let me make it exactly a unitary case, the demand went up by double. So when the price went to half, the demand went by double. Now let's take any of these formulas. I would prefer this one, any of these schedules. I'll take this demand schedule and let's put this in formula. What was the formula? Percentage in change in demand against percentage change in price. So let's go by this formula. Let's take how much is the relative change in both the variables. Here it is 100, here it is 5. So change in demand is 100 upon change in price is 5 into we know that the original value of P, which is 10, and this is into P original upon, or let me write a fresh formula here for you. So this formula further gets derived into change in demand upon change in price into original price upon original quantity demanded. Yes or no? We've done this already. So change in demand is 100. Change in price is minus 5. We drop the sign, so it is 5 into what is the original price? 10. And what is the original quantity demanded? 100. So going by this formula, what we see is that the answer comes out to be 2, which shows that elasticity is greater than 1, which means that there is a greater proportionate change brought about in the demand compared to the change in the price. The demand has been more elastic compared to the change in the price. But but if I look at the revenue, and what is a revenue method or a total outlay method, it's an easier way of checking how much was the revenue by change in the demand brought about by a change in price. So 100 into 100, you were earning 1,000 rupees, and 5 into 200 is again 1,000 rupees. That means by reducing the price, there was an expansion in the quantity demanded, but the revenue stays out to be the same. And if the revenue stays out to be the same, that means that somewhere the elasticity should have been unitary or proportionate or equal to 1, because the change in demand or the quantity demanded rather would have been proportionate to the change in price. But here what we see is that the answer turns out to be highly elastic. That means highly elastic means that if by decreasing the price my demand went further up, then my revenue should also have gone up, but my revenue is constant. Revenue being constant means that if the price was reduced, the demand also went up in the same proportion. Or if the price was increased or raised, the demand should have gone down by the same proportion. That means the revenue should have been the same as earlier, unchanged. That means there's something wrong with the formula happening here. And let's see what's wrong with the formula. Actually, we had taken this formula with the original values at 10 and 100. Let's see another interesting aspect. What if we are now talking about a change in price from 5 to 10 and a change in quantity demanded from 200 to 100? So it's just the reverse of the same case. So now going by this formula, the change in demand and change in price remains the same, but the original value of P and QD changes. Let's see how. Now it is again 100 change in demand upon 5. The only thing is it becomes minus 100 and plus 5. The sign is again removed or dropped. And here now the original price, if we look at it, is 5, and the original quantity demand is 200. So going by this formula now, what we see is that it's turning out to be 1 by 2, which is 0.5, where elasticity is now less than 1. So what you see is, interestingly, if this was the demand curve, which should have been more of a rectangular hyperbola, because there was a proportionate equal change happening in our opinion with the price, between the price and the quantity demanded, but we found that the value was different when we took this as the initial point, and the value of elasticity was different when we took this as the initial point. That means that justifies the fact that we studied that elasticity is different from slope. The slope would have remained constant throughout, but the value of elasticity or the point elasticity would vary at different points of the curve, right? The second thing is, when we moved from here to here, the value of elasticity changed, and when we took the same case moving from here to here, the value of elasticity had changed. So initially elasticity came to be greater than 1, and the second time it came to be less than 1. In this case it was 2.5, in this case it was 0.5. However, in actual fact it should have been very close to 1. And that's a fact also that whether the price was reduced or increased, for the same elasticity, the value should have changed by the same proportion. So now what we do is we try to understand the underlying problem with this definition or with this formula. And the problem with this formula is, I'll again copy this particular part here. So let's again go back to price and quantity demanded. When the price was 10, the demand was 100. When the price was 20, the demand, when the price was 5, sorry, the demand was 200. Now see what went wrong. How much is the change? 5. How much is the change here? 100, right? Now this 5 is a change against 10. If we see, it turns out to be 50%. While this 100 as a change against 100 is 100%. In the second case, when we reverse the values, the change of 5 against 5 was a 100% change, and the change of 100 against 200 was a 50% change. And that was the major reason why, with changing the starting point in both the cases, in one case the change in demand was 100% by 50%, and the other case it was 50% upon 100%. So in order to eliminate this problem, we now refine the formula and we use the concept of midpoint or average elasticity, which says that the concept still remains the percentage change in demand against percentage change in price. But here, this change in demand which we took or in detail it is d1 minus d0 upon, instead of original d that we took, we are going to take d1 plus d0 upon 2, which is the average method. So this is change in demand is nothing but d1 minus d0 upon d1 plus d0 upon 2. We are using the midpoint here. And same thing is now divided by price, which is p1 minus p0 upon p1 plus p0 whole divided by 2. Now obviously into 100 gets cancelled, so that we remove, 2 gets cancelled. So what you get is a formula which is very similar to previous one, d1 minus d0 upon p1 minus p0 into, instead of the original p, we have p1 plus p2, p0 and qd1 plus qd2. So now if you compare this with the previous formula, the only change happens here. It is still the formula for slope, change in demand upon change in price into the average of the demand and the price, which is p1 plus p0 upon 2, 2 gets cancelled, so, and qd1 plus qd0. So instead of the original p0 or the qd0, we are now taking the average, and since these were divided by 2, so the whole thing gets the whole thing gets cancelled, and so the formula is what I just talked about. This much is a formula. If we take this formula, there are always strong chances that your answer will be absolutely correct. So now we use this formula on this same case that we just did now a little while back, and see what the answer comes out to be. So when the price and the quantity demanded are given to you, the price is rupees 10, the quantity demanded was 100, the price was reduced to 5, and the quantity demanded went up to 200. Or it could have been a case of reversal. When the price was 5, the quantity demanded was 200, and the price was increased to 10, the quantity demanded fell down to 100 units. So let's see what happens in this case now. So we see that ideally, because this is a change of 5 and this is a change of 100, right, we are now changing the formula. We are neither taking any of these as the original values. What we are saying is we are taking 10 plus 5 by 2, which is midpoint, or in other words, either we take 7.5, or I may just add the two. 10 plus 5 is 15, so it is out of 5 out of 15, and here it is 100 plus 200, which is 300, and I'm comparing 100, change of 100 out of 300. So now what you see is a change of 5 upon 15 is the same in percentage as change in 100 upon 300, which is a 1:3 change. So 5, 1 by 3, and here also 1 by 3. So that means elasticity in this case should have been equal to 1. So we go by the formula, change in quantity demanded upon change in price into P1 plus P0 upon QD1 plus QD0. And here it is a gap of 100 upon 5, which is the change in price, into the P1 plus P0, which is 15, and QD1 plus QD0, which is 300. And what we see is this comes out to be price elasticity of demand comes out to be, which is a case of unitary elasticity. And how do we confirm that it is unitary elasticity? At a price 10, the demand was 100. At a price 5, the demand was 200. And if we look at the revenue, which is price into the quantity demanded, we see that it turns out to be 1000, and here also it turns out to be 1000, which means the revenue is not changed, because the percentage or the ratio of change in demand as a percentage against the change in the price was proportionate. It was a proportionate change. So having understood this, the formula gets pretty clear that though it is a ratio of percentage change in the variable in the dependent factor against the percentage change in the independent factor, the sign shows the direction and the magnitude shows the level of change that is coming, or the correlation between the two. And so the coefficient of correlation maybe in a way can be considered here as the coefficient being the magnitude of elasticity. So now using the same approach, we can study the elasticity between any two variables. So on one hand, when we talked about For example, price elasticity of demand in the previous example. We can also study the price elasticity of supply. We can also try to understand income elasticity of demand. We can also understand the price elasticity of demand for cross goods, which is the price elasticity of substitutes or complementary goods. So instead of dx, in this case it could be dy, and so on. So any combination of a dependent variable or a percentage change in dependent variable against the percentage change in independent variable can be studied as elasticity, where the independent variable is mentioned here. Elasticity refers to elasticity, and the dependent variable comes here. So we are actually studying the elasticity of the dependent variable against the change in the independent variable. So now, to understand how it is applied and where can it be applicable, we can study the income elasticity of demand to understand the nature of the products. How do they behave? How necessities, comforts, and luxuries vary with the change in the income levels of the people. We'll take that some other day, in some other session, that how the investment in comforts and luxuries starts increasing with a rise in income, and as a percentage increase, the percentage rise in necessities is much lower than the percentage rise in the investment on luxury goods. So the share of luxuries turns out to be much higher with rising income than the necessities. So there would be a different level of elasticity for necessities, comforts, and luxuries with change in income. On the other hand, price elasticity of demand can also be very useful for firms to estimate the impact of change in price on the total revenue and in turn on the profits. And so let me take one simple example to show how pricing decisions or revenue and profit decisions, related decisions, are taken based on elasticity. So I gave you an example in one of the previous sessions precisely, that if you're aware about the magnitude of elasticity of the product, it is easier for a firm to probably take the pricing decisions. However, these decisions are not taken in isolation. There are a lot of factors: understanding your marketing mix, understanding the nature of the product, the size of the target market, the nature of the target market, the nature of competition, and a lot of other factors. But to simplify the whole idea, if we know that the elasticity is going to be less than 1, that means the demand is less elastic or relatively inelastic, we know that any change in price will bring about a lesser proportion of change in the demand. So when we are aware that the elasticity of demand is less, any increase in the price would bring about a lesser change in the quantity demanded, which means that it will help in raising the revenue of the firm and thereby the profits of the firm. But in this case, if the firm mistakes to reduce the price of the commodity, assuming that the demand will go up, the quantity demanded might not rise much and might lead to a decline in the revenue and therefore a decline in the profits. On the other hand, if elasticity was greater than 1, a reverse decision could have been better and favorable for a company, which means that by reducing the price of a commodity, we know that the demand is going to substantially go higher, the quantity demanded is going to expand, thereby raising the revenue of the firm and its profits. While the contrary decision, or the decision of raising the prices, might lead to a much substantial decline in the quantity demanded, thereby decreasing the revenue of the firm and leading to losses for the organization. So this is how the elasticity decisions can help in pricing decisions and thereby revenue related and profitability related decisions of a firm. In the end, I would just like to cover up one more topic very precisely, is that I've been talking about normal goods since beginning, and there's a lot of query, though this is not directly related to elasticity, but what are normal goods? Because normal goods sometimes is a catch-22 situation. Law of demand applies on normal goods, and normal goods are the ones on which the law of demand will apply. But how would you know? If you were to start a new business, would you wait for changing your prices and seeing the outcome to determine whether your product is behaving like a normal good? Or you should already know that how normally is your product behaving, how abnormally is it behaving. And those goods which are not normal might also vary in their level of abnormality. Similarly, all normal goods may not be equally normal. Some may be slightly less normal, some may behave as perfectly normal. So the elasticity would vary depending on the nature of normality of the product. So an easy way to remember and understand the nature of the commodity as normal, I would say that a few points play a very important role. First, normal goods are those goods which are normally more regularly or frequently purchased. So these cannot be, obviously consumer durables are not as normal as buying, groceries, which are more normal in nature because they are more frequently and regularly purchased. The second thing is, so they are regularly or frequently purchased or consumed. Second is, these are the products which normally have substitutes available. That's a very interesting thing to understand, and this can always help you determine why two normal goods also might vary a little in their intensity or in their elasticity, because their level of normality might also slightly differ despite being normal goods. So substitutes, if a product has more substitutes, there is a greater chance that it will behave like a normal good, and any change in price will bring about a change in the quantity demand. Third is, if a product has alternate or multiple uses, there is a greater chance that it will behave like a normal good, because with a change in price, it will be easy for you to cut down on the less important uses and only continue with the most relevant ones, and vice versa. But goods which do not have more substitutes, or goods which do not have multiple uses and have more specific units like petrol, for example, would not behave like a normal commodity. And then we also say that due to these factors, we may see that normal goods are the goods on which you see the application of law of diminishing marginal utility. So we see the law of diminishing marginal utility also applying to these products because of the above factors that I just talked about. So normal goods are the ones that witness an impact of law of diminishing marginal utility on them. Another point, last point that we may also further add to this, the normal goods are the ones which may not either be completely holding an insignificant part of your budget. That means something so small in your budget that it really does not affect you much, and nor at the same time it's a substantially high part of your budget, but it's a very noticeable part of your budget. So normal goods are those goods which occupy a noticeable part of your budget or your income, and that's why any change in the price affects you, and because of this effect, there is a possibility of a quantity demand changing as part of your expenditure. So I think that's the end of it today. I hope you understood the concept of elasticity, and concept of elasticity further helps in a lot of decisions by consumers and by producers or the firms when they're taking their consumption or production or revenue, sales or profit related decisions. So all the best. We see you in the next video. Thank you.